Good morning, all of you. So, oh, very less attendance. What is the reason? Voting, huh? Very good. So, guys, today I'm going to show you lab of whatever we discuss worker node components. So, the worker node components. Okay, so we are going to discuss these many concepts in Kubernetes, guys. Okay, so it's a 22 modules. It's a 22 modules. So the important ones. So Minikube is just process for installation. It's not required. You can just exclude it. So EKS installations, worker node components, services, ingress, schedulers, horizontal pod auto scaling, node high availability. Okay, RBAC, rolling update, namespace, volumes, stateful set, config map and secrets, monitoring, Helm charts, Argo CD, probes, CubeADM, ELK EFK stack, project, and I think Miss Grafana and Prometheus. These many concepts. Okay. So yes, out of 24, so ELK you can exclude it. It's very, contains big files. I will show you that everything is already prepared. The blocks also. Just step-by-step process. What YAML files are required to deploy EFK stack. Everything is ready. Just run the deployment of EFK stack. That is the last day we can see. Okay. And our focus is first EKS installation. EKS. What is the process for EKS? Already in the last class, I have already shown you, right? How to create EKS cluster? No, na? Okay. So worker nodes, services. So already discussed worker nodes and services, right? Worker nodes means what and all there? Pod, deployment, replica set, whatever, horizontal pod auto scaling, so many YAML comes under. Services means what? Three type of services: cluster IP, node port, load balancer. So in real time, we are using load balancer only. Okay. So anyway, guys, the process is to launch your EC2 mission. First, we can discuss. Yeah. Okay. This is the command to create EKS cluster. So before that, we need to focus on some prerequisites. For that, where you are going to create your EKS cluster, that instance required roles permissions. For that, create a IAM role and give the EKS permission or administration access for the practice, and then run this step. Okay. Or instead of administrator access, you can give this access also. EC2 VPC cloud formation access. This three is required to launch EKS cluster. These permissions are required. Why? Whenever you can run this command, the background cloud formation will create. That cloud formation is nothing but infrastructure as a code. We learned already Terraform, right? But AWS Terraform is cloud formation template. That is only for AWS. Terraform is support to all clouds. Understand the difference here? So since we are running cluster in AWS, that is EKS cluster, Elastic Kubernetes Service, definitely they can follow the background cloud formation template to give the infrastructure related to EKS. Understand? Sir, can we do it by using Terraform? Yes. That is also already done. I will show you one day how to create cluster by using Terraform. Okay. So in that case, cloud formation will not create the background. You are creating by using Terraform, right? That's it. Understand? So this is CLI approach, command line interface approach. If you want to create manual approach, you can create manually also. Go to EKS. Go to EKS. But manual approach is not recommended. The reason is if you create a cluster, okay, if you create a cluster here, many dependencies will be create the background. While deleting time, maybe the manual approach, the dependencies at that time, it will not be deleted. You need to delete everything from the manual process. But CLI, it's work like a based on API. If you create cluster, it will be create. If you delete means it will delete everything. Single command we can control. But real time, we can create cluster by using Terraform. Okay. So 3 approaches already ready. So manual approach means, so this is EKS cluster. You can give the name and you can give the role. Okay. And just next. Role is required to create EKS. So you can give any role, we'll see. And next, on which VPC it has to select, create, and which subnet. I'm giving all subnets. So which security group. So public access or public private or only private, you can select. And next. And next. So, okay, these many details it configure automatically. Next. If you create next. Pricing and all it is showing this template, create. It will create on which VPC cluster will be created, and which subnet, which security group, everything same steps like EC2 creations. But this is not recommended, better to go for CLI process. So when I say CLI process, you have to log in any EC2 mission. From the local also we can do it. But better to go with EC2 instance only, not from the local. So for example, this mission, from this mission, I'll just create from the cluster. First, this mission permissions required to create a EKS cluster. What kind of permissions? Cloud formation template. Yes, EC2 instance, VPC full access. If any error will get, that permission also we can give. I mean, this mission able to create EKS means we should give the EKS dependencies permission to this mission in the form of IAM role. Is this clear? Yeah. So now, as we know, EKS cluster, Elastic Kubernetes Service, cloud managed Kubernetes. In that case, we need to define how many worker nodes required. In a Kubernetes architecture, we already discussed, we have a 2 type of nodes, control node, worker node. But our work is to on worker node only. Control node is manage the worker node with help of control node components. So control node components run in control node. If you go with Kubernetes, cloud manager Kubernetes, that control node related components and everything taken care by cloud providers. We can see only worker node. Best example, RDS managed node. We can create RDS cluster, but we are unable to see the RDS instance in the EC2 console. That EC2 instance is not in our responsibility, so that we cannot see that instance. Taking care by cloud providers. Same thing EKS also. Control node is taken care by cloud providers. Whatever instructions we can give from the terminal, the instruction will go to directly control plane. From the control plane, it will come to worker node. Sir, how the request will go to control plane? We cannot see. The reason is managed by AWS. If it is Azure, Azure. If it is a GCP, GCP. Clear? So our entire focus is on only worker nodes. Our deployments only on worker nodes. Okay, not in control node. Is this clear, everyone? Okay. Please check Pawan your end once. Okay. So guys, EKS Kubernetes definitely will support worker nodes. So minimum required is only 2. Minimum 2 nodes required to deploy EKS Kubernetes. The 2 nodes means worker nodes, not control node. No need to define here control node information. If you create EKS means by default control node will be created. No need to mention any steps in that. Regarding worker node, we can define size of the EC2 mission, size of the worker node, how many required, minimum required, maximum required, we can define into your CLI command. So for example, if you can see the CLI command, create your cluster, EKSCTL, create cluster, name is cluster name, region and which region and which node type and how many instance required, how many instance required for the maximum. You can give it. For example, if I give minimum 2, if I give maximum 2, so maximum 2 means if traffic is more, the nodes will be created by configuring auto scaling group. Anyway, I will show you one by one. So this is the command. So definitely you need to define the region and a node type. But here there is no minimum maximum, right? So whenever you can launch the EKS cluster, by default, it will create 2 nodes if you're not define anything. If you want to define, you can define how many minimum required, how many maximum required. Okay. So we can do one thing, our practice purpose, go with the default one. If you can create multiple means, your free term may be expire shortly. Better to go with 2 only. Don't create 3, 4. What we can plan, we can do the practice with the 2 nodes. Finally, we can create 5 or 6 nodes in the final day. That time, no problem. In the project also, definitely, I want to show you here 6 nodes. 2 nodes are not sufficient in this case. Otherwise, 2 nodes, I can take large instance. If you can take a small, you can increase the count. So 2 are same, right? Increase 2 nodes, large configurations, or increase the count of nodes, minimal count. Both are same, right? So that if you want to increase the size, we can change instance type T, instead of T to small, you can give the T to large. In that case, count might reduce. Okay. So to install EKSCTL cluster, first we need to install EKSCTL into your local laptop. I mean, your EC2 instance. And see, to install EKSCTL, we need to follow these commands. It will be available in document also, just I'm saying. And whenever EKSCTL install, you can create a EKSCTL cluster only can understand. See this command, start from EKSCTL. So definitely we need to install EKSCTL first into your local laptop. Otherwise this command not found error will come. And the very important thing here, kubectl. So the kubectl is the Kubernetes specific command line tool. I mean, whatever instructions you can give into the Kubernetes with the help of kubectl instructions. Kubectl or kubectl, both are same. Docker instructions will work on the Docker term, Docker run, Docker image. Kubernetes, all instructions will work based on the kubectl instructions. In that case, what I need to do? Install kubectl also. EKSCTL is the command. Cluster, I think your question is cluster. Cluster is region specific, not global. If you can see, that's what we have to define region here. Okay, here, region, see here, region. It's not a global specific. Okay, is this clear? The first one is what? Create a instance, create an instance. That instance we can give the role. The role contains all cluster dependencies, VPC full access, CloudFormation full access, EC2 full access. And then to run EKSCTL cluster command, first we need to install EKSCTL. To worker nodes, kubectl will work. To run that kubectl commands, we need to install kubectl also. Understand the logic here? Yeah. So my instance, first I'm going to install kubectl. Kubectl is a command line interface between your instance and worker nodes, Kubernetes. Okay? Yeah. So for that, I'm going to install kubectl first. Okay. This is the instructions to install kubectl in my, if you can go to day one installations also, installations process. So how to set up EKSCTL, how to set up kubectl, everything is updated here. Okay. Okay. So first download kubectl version 1.20, whatever it is, no problem. Okay. And then grant execution permission to kubectl. Why? The all commands executable by using kubectl. For that, first we need to give the kubectl permission. Otherwise, it will not execute, right? For that, chmod plus x executive permission. In our language, we can use chmod 707, whatever. And then this kubectl, we need to move into the bin. All commands will execute in the bin. So we are just moving to the bin permanently. So that kubectl commands, whenever you give the command, it will go to directly bin. Then check the version. Clear? Let's run the first one. So my instance is ready. My instance is ready. Okay, sudo su hyphen. So first I'm going to create a install a kubectl. Done. Let me check space. Okay, space is there. And then what is the next step? Move kubectl onto bin. Before that, grant execution permission. So for that, see, I'm giving grant execution permission. Okay, and next step is what? Move to bin. Already there, no problem is overwrite. Okay, and then kubectl version. So let's go and check kubectl version. Okay. Let me check kubectl command working. Okay, it is working. Kubectl command is working. So then next one is what? EKSCTL. Okay. EKSCTL I'm going to install. Why? Cluster create EKSCTL create cluster. So definitely EKSCTL should install first. Otherwise the command will not run. What is the first command? Same like kubectl. Copy. Okay. Okay. And next, what is the next step? Same. Move to bin. Same. This one also move to bin. and EKSCTL version. Okay. So EKSCTL is there, kubectl is there. Now what is the next step? Create a cluster. And this instance already I have attached role. If it is not there means cluster will not create. So what we can do, this instance role I can check here. EC2 EKS. Okay. EC2 EKS. The role name is, I have given administrator access, I think so, whatever. In your case, you can give administrator access or whatever I have mentioned here. Here the permission, required permissions you can give. Okay. Create IAM role and attach it to EC2 instance. Node create IAM user with programmatic access if your bootstrap system is outside of the AWS. And IAM user should have access to IAM EC2 VPC CloudFormation. Create your cluster. So what is the process to cluster creation? EKSCTL, create cluster, name you can give anything, region you can give anything, node type you can give anything. So if you can see here, my cluster name is headless. Just I'm giving headless cluster. You can give any name. Okay. Cluster process is started. Now, if you want to check, go for CloudFormation. What happened? I think my this error is coming. Unexpected status. Okay. Okay, got it. Minimum VPC numbers. So change region. So guys, whenever you can create a cluster, the background subnets and everything will be created. Okay, already in region, in your region, your VPC's limit is 5, right? Already in your region, 5 VPCs created. So cluster will not create one more VPC. So that change the region or delete your existing VPCs, whatever. In Terraform, I will show you in detail way. So how to choose specific subnet and specific availability zone and VPC. So here just we are giving one command. Kubernetes will create the required infrastructure and everything background. It's a default infrastructure, but we can choose our infrastructure. First node you can create in only this instance. Second node you can create in only availability zone 1B. You can give, we can give. Okay. So cluster is creating, guys. If you can go for CloudFormation, you just refresh here. So not here, right? US, which region I have given? East to Ohio region. So if you can go for here. So here cluster is in progress. Okay. So the background, it will create everything. If you want to have a look here, the EKS cluster and resources, stack information, template. This is the EKS template, CloudFormation template. So whenever you can give the instruction, the background template will be created automatically. Let's see here. Okay. So guys, meanwhile, we can discuss something. This instance is not control node. Don't confuse. This is just hosting the node only. To give your instructions to Kubernetes, we are using this EC2 instance or local laptop. Don't confuse. This is not a control node. See, if you want to give instructions to your Kubernetes, we need to run one command, right? Understand? We need to run one command. For example, create a pod. kubectl apply -f pod aml file name. Pod will create. So here instructions you are giving from one server. To give the instructions, we need one server, either laptop or server. Same thing. If you want to deploy Terraform infrastructure, for example, we can deploy in EC2 instance, right? We can launch Terraform infrastructure from EC2 instance also. In that case, Terraform is not created that EC2 instance, right? We are using to run your Terraform instructions. We are using one EC2 instance. Otherwise, same instructions we can run VS Code also. If you run VS Code means indirectly you are run the command in your local laptop. With help of user credentials, you are able to connect to your AWS environment, run the Terraform instructions. Same Terraform script I can run in EC2 instance also. I can clone the Terraform infrastructure. I can run Terraform init plan apply. In that case, we are using instances to run your Terraform commands only. That instance will not decide anything of Terraform, right? Only for help to execute the Terraform commands. Same here also, this instance is to only execute the Kubernetes commands only. This instance will not take any instructions. This instance will not control any worker nodes. Based on your commands only, it will pass to control node. Control node will apply the changes into worker node. Understand? It will take 30 minutes or 20 minutes time to create a cluster. So now let me show you something in the architecture. Don't confuse. This is a little confusing way. So guys, if you can see here, we have a worker nodes, right? So now by default, two instances created, worker node, two worker nodes. Two worker nodes means it's like EC2 instances only. Okay. Now this is your EC2 instance, normal EC2 instance. Okay. Okay. So we can give the instructions from this EC2 instance. That's it only. So we require control node, right? We require control node, right? This is control node. This is managed by AWS. So we need to say to control node, right? I need two worker nodes. I need three worker nodes. I need to run a pod. Everything instructions go from here only. Understand? This is taken care by AWS. So control node components already we discussed, right? Each control node component. Then someone has to give instructions to control node, right? kubectl apply, kubectl delete, kubectl run. These are instructions what you expecting from this worker node. That we are passing from this EC2 instance, right? Whenever you can give the instructions to here, kubectl apply, the request will go to control node. From the control node to worker node. So this is not controlled directly. Is this clear? In the last class, we already discussed, this is the laptop, this is the AML file, first request will go to API, right? So my AMLs we can see here. Whenever you can give the instructions, kubectl instructions. Kubectl instructions will go to control node. Okay. So here, control to worker node. Understand? So actually, based on your request, it will go to control node. Based on the request, control node will control. This EC2 is to run, to maintain YAML files, to run kubectl instructions. We are using this EC2 instance. Yeah, whatever you can understand. But it will not go the request like directly. It will go through control node. This is managed by AWS. We cannot see. We can give the instructions. Indirectly, we are saying to control node, run the my, please run to my pod, delete my pod, whatever. Clear? So in that case, I have created two worker nodes. It is on process, two worker nodes. So we can see the two worker nodes in the whatever region you are going to create. Is this clear? Yeah. And one more thing, let's go to Terraform. Okay. So if you can see here, I can define here my availability zones, public subnet, private subnet, whatever. I can just give here. I'm going to create VPCs. I'm going to create subnets and everything here. So better, this is not a clear. For you, I just created full stack project here. So this project is on progress, so it will complete shortly. So if you can see here, EKS main.tf. So I'm going to create a role and attach the respective policies. This is for this role and policies is for your cluster, not for your instance. Understand? So if you can see here, guys, if you observe here, whenever you can create a cluster, the background policies, roles, and everything will be created for Kubernetes communication purpose, not for your EC2. Your EC2 role is already given. That is to communicate your Kubernetes. But inside Kubernetes, we have a nodes, right? Nodes, worker nodes. For worker node communications to control node, the background roles and policies also created. Okay. This roles and policies by default is created, but through Terraform, we need to define. Okay. So, but Terraform, we need to define. So if you can see here, so autoscaler, S3 permissions, I mean, these many permissions I'm giving to my cluster, not for my EC2 instance. So for that, just I'm creating a roles and policies and leave it. If you can see here, I'm using data block to call the VPC using subnets, subnet 1, subnet 2, security groups. I mean, my cluster, two worker nodes, right? One worker node in one subnet, one worker node in one subnet. Finally, two subnets in one VPC. So every time cluster creating, we no need to create VPC and subnet, right? Already VPC subnets are there, means we can give that existing VPC subnets by using data block. So if you can see here, I'm going to create a node group. In the node group, my instance type is T2 small, disk size is 20, capacity is on demand, subnets I'm calling by using data block, what I define. This is role. Okay, if you can see the scaling configurations, desired is 2, max is 1, minimum is 1. So if you give like this, for example, now desired is 2, right? 2 worker nodes has to create the 2 worker nodes, which subnet, which availability zone. That's what I have defined here. Subnet IDs giving two subnets here. So one instance one worker node can land into the one subnet, one worker node can land into the second subnet. Okay. So like that we can give the subnets. I'm not creating here. See, there is no resource block for subnets and VPCs. Only data block means this already created. So I'm calling these VPCs subnets and security group attaching to your node group. That's it. Understand? And if you can see, what is this? Okay, here is not there. Yeah. What is this? This is your main instance. Main instance means now we have this EC2 instance, right? Running the cluster in this EC2 instance. I mean, sorry, not running in that. You are creating cluster by using this EC2 instance, right? This EC2 instance also we can go with Terraform. Understand? So in this EC2 instance, kubectl will work means definitely Docker should run first. In this EC2 instance, I need to install Docker, Kubernetes. If you want to control the entire process by using Jenkins, I need to install Jenkins. And I need to analyze the code quality, I need to install the SonarQube. So, if you want to clone the repository, I need to install the Git. Everything I should install, right? On one EC2 instance. So, if you can see, this is the instance. In this instance, if you can go for install.sh, these many tools I have configured. Whenever install your EC2 instance by using Terraform, Terraform will install in the instance the required all the tools. I mean, no manual process. Whenever launch this EC2 instance by using Terraform, that instance download all the tools. Okay. And jump host TF means we can call this is jump host server. By using this jump host server, we can control everything. Okay. Yeah, if you can see in the jump host server, I'm not hard coded anything. If you can go for the first step is this server required IAM. I have created IAM role, attached policies, and created IAM instance profile to attach EC2 instance. I mean, if you can see here, this is my EC2 instance, already attached role, right? Manually? No, by using Terraform, creating role, attaching permissions, and attach to your EC2 instance. So IAM permissions, I'm giving the same EC2 instance. What I need to install, I'm giving here by using installer tool.sh. And if you can go for vpc.tf, network, on which network this instance is going to be created. So if there is no network, see if you can see, I'm going to create network also, the background network, everything. I'm not using default network for that instance. So if you can see, same process, internet gateway, VPC, subnet allocations, route table, security groups, ingress, egress, network done. In this network, my instance has to be landed. For that, this is the jump host 2F. So I'm just calling AWS subnet, whatever you just created. I'm just calling security groups. I'm just adding instance profile to attach a role to your EC2 instance. All I'm calling here only. This is for install your all tools, user data. And output the TF for your whatever instance you have configured. These are the output blocks. And variables, these many variables for your instance. Understand? So if I run this Terraform script from my VS Code, one instance will be created and install all the dependencies, EKS, CTL, Cube, CTL, everything. Just now have installed EKS, CTL, Cube, CTL, right? That is EKS, CTL, Cube, CTL also, see here. I mean, ready to work now. No need to install manual process anything. If you launch this server, everything, policies, permissions, install configurations, everything will come. Now what you need to do, start your work. How to start? Jenkins login, start Jenkins. See here, Jenkins also there, if you can see. Directly take the public IP, give the port number, log in your Jenkins server, configure all tools. First is what? Clone the repository, static code analysis, and Docker build, deploy Kubernetes. If it is a tree scanner, and then run the Jenkins pipeline. Understand? Source code and all will take from Git. For that, Git also I'm installing. This is the process we are following. But cluster is required, right? Cluster, we should not create any dependencies in the same VPCs and all. We need to create separately. For that, if you can see, whenever you create this Terraform, first this infrastructure will be created, VPC, subnet, ESUT and all. Now, next step is what? We have given EKS cluster creation by using CLI command, right? But it should not CLI command in the real time. Actually, Terraform. If any, for example, now 2 nodes, now 3 nodes, if you want to configure VPCs, if you want to configure subnet, if there is no Terraform, CLI will not help. For that, I'm going to implement EKS Terraform script also. When I can run this? After creating this Terraform. So anyway, I can configure this block by using Jenkins. For that, what I need to do, whenever this Terraform will run, Jenkins will create, take the Jenkins login, write a pipeline script to clone the EKS Terraform script from the Git, and Terraform init, Terraform plan, Terraform apply. EKS cluster will be created, right? So 2 process done, right? Then your pipeline, write one more pipeline. The pipeline is for main project. First Jenkins is for EKS cluster. Second Jenkins is for your main project. Understand the difference here and there? So everything is automated, no manual process. But first Terraform script we can run from your local laptop. I mean execution, VS Code. Otherwise, client is asked us to know this execution also in the Terraform in the AWS cloud means at least one instance we should create manually first. Understand? That also Terraform means again we need to create one more manual instance. See, first one instance is available in your business account. That instance we can clone the repo, run the Terraform init plan apply. First EC2 will be created. Then login and Jenkins pipeline configuration. The first EC2 also go with automation process means definitely the Terraform can execute from the local machine only. Understand what I'm trying to say? See, this Terraform, if I want to execute from the local, see the difference here. So for example, this Terraform I want to run first time. This is different project, leave it. This Terraform want to run first time, definitely you need to execute here only. Understand? And then you can log in and do your next process. No, this also can execute not in local, in cloud means definitely one instance should be created manually first. And clone entire repo, run your first EC2, first Terraform script. Understand the difference? So what I did, I can run locally first. Everything will be created first EC2 along with infrastructure and permissions and tools configuration. I'll just go and log in my EC2 instance, take the public IP, port number of Jenkins, login Jenkins, configure EKS script. And next, write one more Jenkins pipeline for main project. Understand? Yeah. So my EKS cluster is created. Meanwhile, so if you can go to my cluster, North Virginia, right? So what I'm going to do is switch from here to Ohio region. See, 2 clusters created, right? Sorry, 2 nodes. Is this correct nodes? What is the time? No, not this one. Headless. Why only one created? Sorry, here also there. 2. Let me delete this 2 first. Okay, if I delete, again it will recreate. Let's go to Ohio region first. EKS cluster. Okay, this one also there now. Okay, let me delete this one. Control C, Control. Okay. See, this is the problem. Manually operations. First we need to delete something and a node group. So node group means click on this first. So go to compute. First we need to delete this node group and then delete the cluster. Manual process. Or we can delete EKSCTL delete cluster, a region name. You can give this one. You can delete it. Okay. Let me delete. So EKS. Let me clear the screen. EKSCTL delete cluster hyphen name, paste, and give the region also hyphen region US East 2, right? US East 2. Okay, the cluster is going to delete. So meanwhile, I can open the duplicate tab for this to work other process. Okay, so US East 1, go for North Virginia. So my instance is there here, right? Okay. Okay. This is my EC2 instance. From here only I have created EKS cluster. From here only I'm deleting EKS cluster. So the deleting process already going on. Meanwhile, I'm just open one more tab to start our work progress. Okay. So Linux is supporting same instance, multiple operations. Okay. One process already going on in the same instance. Now I'm going to apply one more process, multi operations. Sudo cipher. So now the first step, you have created nodes, right? How many nodes? 2 nodes. Why nodes required? To host our images. I mean, create a containers. So pods, the pods will be run into worker nodes, 1 or 2. So the first command is kubectl get nodes. See, 2 nodes created. From this only I have created 2 nodes. For example, in your end, if it is not updating, if it is asking any update process, you need to run this command. Okay, AWS EKS update kubeconfig region and cluster name. Okay, the reason is, let's go. cd dot kube ls vi config. It has to update in your local server. You created from here, right? It's information. So if you can see here, your API authentication, this is your ARN, your cluster ARN, and this is the permissions and all. Okay. So these many, this is the key. So it has to update here like this way. So if you can see here, 2 clusters I can see. The reason one is for, I'm deleting now, right? That one also created from this EC2 instance only. That's what I can see, 2 updates here. Okay. See here, project EKS is the 1 cluster and deleting now quiz app EKS cluster is deleting now this one also. After delete the cluster, it will be gone from here. This information. So it has to update after creating the cluster into your local. Okay. It will be updated into dot cube. Okay. Dot cube and inside config. So if it is not updated in your end, you are unable to run kubectl get nodes command. So what you need to do, you need to run this command to update your kube config. Okay. If you run this update kube config, it will be updated, created .cube and updated into your local config file. Then your instance can communicate with your cluster. Understand? This will be not, some cases, if it is not updated means you need, if you want to run, if you run this command, the .cube it will update into your local so that that instance can communicate to worker nodes. This is mandatory step. Okay. Okay. See guys, if you can see, we can start the work now. kubectl get nodes. I can see the nodes information. See, if you can see here, this is the name, status ready. There is no roles. Age is 14 minutes. Version is 1.29 version, Kubernetes version. So in the nodes, if you want to see the node IPs, if you want to see the specific information, we need to give -o wide command. -o wide. If you can give, we can see the same nodes enter information, internal IP, external IPs. Internal IPs is for your internal Kubernetes cluster. External IPs means our EC2 instance IPs. If you can go to see headless, if you can go for headless one service, this is the 18.219.210.35 is the public IP, right? External IP, public means. If you can check here, see 18.292.135 is the external IP. Clear? So the first command is kubectl get nodes. If you give -o wide, we can see that enter information. If you want to see the more information, we need to give the describe command. So -o wide, we can show the high level IPs level information. -o wide, we can see the IPs level information. kubectl describe node, the node name, any node name if we can give. We can see the entire node history here. So after kubectl describe node, okay. So if you can see annotations, yeah, unscheduled, nothing is there, so false. Memory, so sufficient memory related informations, internal IP, external IP, internal DNS, external DNS, CPU is one allocation, storage is allocation like this way, allocate, sorry, in this storage, allocate this one 940 millicore. So it can support 11 ports, I think so. So like that, enter information, kube system namespace, okay. So we can see enter information. For example, your node is not deploying. Your node, some issue is there. Okay. For example, you have given set point 4 nodes, 3 only creating, 4th is not creating, getting an error. We can see the kubectl describe node. We can see the here the problem is there. What is exactly problem here? We can see the node level. Same apply for pods also. kubectl describe pod, your pod name. Same for service also. kubectl describe service means SVC we can give. We can check -o wide describe. All it will apply for all commands. Understand? Okay. So anyway, in the nodes, everything is very clear. Okay. Yeah, guys. So in the Kubernetes workloads, we can give imperative and declarative. Imperative means single commands. Run the, clone, pull the image and run it. Same command itself it does. But we are not using any imperative. See Kubernetes run pod -f image nginx. I mean, it will pull the nginx, it will run the pod. It is imperative. Pull the nginx image from where? Docker Hub registry. Why? Kubernetes is linked with your Docker, right? So it will, whenever this instruction will give, immediately Docker will pull the image and hand over to Kubernetes. But the same image, instead of run the imperative, we can declare like this. Last time we discussed, right? So pod, metadata, myapp, labels, nginx, same. This command, okay, this command, this AML, this command, both are same. But here, we can define so many things additionally, labels, and here we can just use for temporary purpose only, imperative. But declarative, if you can see, this pod is run on this name with this label with this image. Understand? These labels will work to call any service for this pod. We can use these labels. I will show now. Of course, if we are pulling image, definitely we need to give the ECR full access. Okay, let's come now. So we can see in the my GitHub, we can take the worker node components. Okay. So let's take the worker node components for today. So pod. So this pod is Nginx image only, right? Copy it. Delete it. Huh? Okay, close this one. So now vi give your pod name, whatever name you are going to give. You can give first pod if you want to give, but extension should be YML. Okay. Okay. Paste it. Clear? So now WQ. How to apply this pod? kubectl apply -f first pod.yaml. Any deployment service pod, this is the command, apply -f. That's it only. Your YAML file. Delete kubectl, delete -f, your YAML file. Understand? So if I run this command, see here, pod is created. Nginx image also clone and also run. See quickly. Kubernetes is very powerful tool. Now I want to check the pod running or not. What is the command? In place of get nodes, use the get pods. That's it only. See, my pod is running. My container is creating one by one, means pod is running, container also running. 25 seconds ago. Your pod is running which node? How do I know? Describe or -override. We can see here. So, okay, describe kubectl, describe kubectl get pods -override. If you can see here, this is running in this node. Okay. In this node, it is running. If you want to see the information in detail, which image, everything, kubectl, describe, pod, what is the pod name? My app. See in details, pulling image, Nginx, successfully pull 4.3 seconds. After the creator created a container, started a container. Understand pod, Kubernetes first pull the image, start the container and created a container. That image is what here? Not custom image. The image is public image. Here path of the image where I should provide it here. This is public Nginx image. That's what Kubernetes pull the image from Docker public hub repository. If it is a private image, ECR means maybe ECR or Docker private registry we have to give here. Then it will clone from your ECR or clone from your Docker private hub registry. Understand? Okay. Now I'm going to modify here the labels. Okay, not now. Let me keep as is. My pod is running, right? My pod is running. The pod contains what? Nginx. Now I want to give access for Nginx pod to outside. How to give? Required service. Required service. So how to check the service is created is kubectl same get service or SVC. Shortcut SVC also will work. See, whenever you can create a cluster, by default cluster IP will be created. This is the cluster IP for Kubernetes process. If you create service or not, one cluster IP will be created for default communication, your node and pod inside. Okay. Now I want to create my service to give my pod access to public. How many services we know? 3: cluster IP, node port, load balancer. Cluster IP is for internal communication, already discussed, right? External it will not work. We have two options: load balancer and node port. Let me check with node port first, then we can change it into load balancer. Okay. So go to service here. So in the service, go for node port. Okay. So go for node port. See guys, let me create the service, copy. Let's go for Kubernetes document also is very good. So Kubernetes documentation is very clear, guys. If you can click pod here, you will get the pod information, Kubernetes, what is pod, how it will work, what is the sample image of the pod. Okay. So if you can see, is there any labels? No. So we cannot create service for this pod. Understand? In that case, what I need to do, add the labels here. Then your service can communicate. Anyway, so this is the process of the pod creation and all. So now I want to create a service for this pod. In that case, what I need to do? Copy. You can create in the same pod YAML file also service also by giving these 3 spaces, 3 lines. Otherwise, create special file also, no problem. So in that case, let's go and VI. Okay, before that, go for Notepad for better understanding. This is my service. Okay, this is my service. And go for pod. VI pod. Okay, VI first pod dot YAML. This is your pod. Okay. Tell me, guys. Now I'm going to give service access to my pod to give access from the outside. For this case, this service I'm going to create for this pod. What I need to do now? If you can see, spec is the node type. Okay, these ports I will discuss later in one class. Anyway, we can understand the target port is 80Y. Nginx is run, default port is 80. That is comes from the target port. The target port is whatever your application by default it will run. That is a target port. Is this clear? Node port. Node port is nothing but one more port is going to create to give the external access. Okay, we can discuss later for this point. Anyway, first how to communicate this service to this pod. What I need to do here. Okay, my pod label is what? App, web app, or type frontend. Anything we can give. This service is what? Label is what? My app, NP. But what I need to do now? My app. Is this clear? I'm saying this selector, you can connect this pod. This pod is what? Name my app, right? So what I need to do here? name my app. Sorry, app only. Okay, understand this app, my app, this app, web app. Sorry, web app. Okay. Okay. So this will link with your selector. Your service can link with your pod. Is this clear? Let's do it. We'll get on error. Copy. Okay, pod keep as is VA svc.aml. Any name you can give, no problem. Paste WQ. Okay. So now service is there, pod aml is there. Pod already created, right? Now what I need to run now? svc.aml. Service also created. Pod also created. Service is giving access to your pod or not, we can check now. Now how to check the service? kubectl will get svc. You created service, right? Once you create a pod, kubectl will get pod. Once you create a node, kubectl will get node. Once you create a service, kubectl will get service. Okay. See, if you observe one thing here, 32473. One service is created, but 32473, what it is? So let's come to Google. See guys, whenever you select node port type service, okay, by default, Kubernetes system allocate the any port in between 30,000 to 32,767. This is by default they will provide. So if you want to access your application by using node port, what I can do? I can take my public IP of your EC2 instance, node public IP, and give the whatever port number allocated node port number, that port number. Okay, if you can see here, this 8 is what? Target container, where application is running in the port. That port we are forwarding to 32473. Same like Docker. Docker -p, localhost port, and actual port, right? It is forwarded to given port number. The given port number is here, this node port. Understand? That condition, we have to define whatever port you required. This condition, we have an AML file. We need to create a node port AML file to give the public access. That AML, if you mention node port, they will allocate the port number 30,000 to 32,067 something is there. In between, we'll get a 2,000 some hundred port numbers. Any port number they will allocate by default. In that case, this 80 is forwarding to this port number. Now IP, which IP I need to use? This IP. This IP is your local instance IP, not this one. Where exact application running? Worker node. So worker node IP plus node port number. Understand? So how to check the worker nodes? How to check the worker node IPs? kubectl get nodes -o wide. If you give me, we can see the internal external IPs details. Understand? Now take any one of the external IP, any node, copy. What I need to give here? 32473. 32473. Okay. Yeah, I'm not getting any response, right? So I need to enable 32473 port in where? Security group. So what I need to do? Oh, time 10:30 now. Anyway, see, I'll just open one of the worker node. Guys, leave about for your source instance. That is for only help to give the commands only. You cannot do anything in that. Go for security. Click on security group roles. Okay. Inbound rule. Source is only SG, not for external, right? So go for inbound rule. Add rule. This is 00. External, right? So given. See, welcome to Nginx. Okay. This is node port. What about load balancer? Your work is to do load balancer. Same. VASVC.aml. Instead of node port, just change load balancer only. If you do like this, one load balancer will create in the same region where cluster is running. That load balancer you can access. Understand? One load balancer will create into your local, which, for example, your cluster is running Ohio region. In the same region, one load balancer will be created. Go to EC2 console, take the load balancer, hit here. You are able to see Nginx. Understand? That is load balancer type. But real time, you are using load balancer type only. Why? Here indirectly your IP also exposing, right? Not recommended. And I think someone is asked, sir, what is the use of labels? So if you can see here, my SVC, my pod is running, right? For example, if I go for SVC now, my label is what? But what is this label? What is this label? This is for service reference label. If other service is talking to this server, other service target and add this label. This is for not reference for pod. This is for your service reference labels. If it is there or not, no problem. Other service want to communicate this service, how it can communicate based on the labels. Which label they need to pass? This label need to pass in their target. Understand? If you can see this and this target, right? This source is there in where? Our pod label source. If you can go and check our pod labels, you can easily understand. See here. I'm calling this label into my target selector. Type frontend I'm not using. You can add type frontend also. Understand the difference? Just I'm giving two type of labels. Any label, one label match is fine. No need to map two labels. For example, yes, my pod is running. vi svc.aml. This time I'm going to change. Okay, I removed one P here. You need to apply the changes. Understand? kubectl apply -f svc.aml. See, configure, right? Now, if you can see kubectl get svc. Okay, same 32473, right? So now you can hit Control C. Your service is not linked with your pod this time. That's what you are not getting any response. Clear? Maybe this is cache. let's take, yeah. See, this is our one. Okay, new one. See, understand the difference here and there now? Why your service is wrongly configured? Your label is not mapping in there. So again, what I'm going to do? svc.aml. I'm going to add p kubectl configured. You see, immediately coming here also. So that is the difference. Okay. Sorry. You are running same YAML file, right? Terraform main.tf is there. If you run three times, 4 times, same YAML can execute or different. Here also same, right? If you create one more service YAML file, that can execute. But you are working on the same edit, apply, not for creating one more service, right? You can create one more service YAML file, VI different name. That case, two services can create. One is for load balancer, one is for node port. But you are keep on doing the same existing service.yaml means it can update only, not for create fresh one. Same thing in our control node and worker node concept I already discussed, right? The request is coming from the same YAML. Controller can understand, okay, no need to create fresh one, it is already created one. Okay. Hmm? How many? One server only. Here is we are not, control node is only one. It cannot create 2, 3 control nodes. Standby they can provide. If it is fail, same controller will be created immediately. That is taken care by them. But here, if you want to check here, there is a config file we can check here. But it will not get any information by using kubectl command, the controller information. Okay. So that's all for today. Time is already 10:35. So what you, I'm going to update the GitHub for you for Kubernetes series, day 1, day 2. I'm going to add a few files, just practice it. Okay. I mean, just I have discussed here only pod, right? So you can try deployment replica set also. The difference is what? Replica set, deployment, number of pods can increase. Why? Replica concept is there. But here, there is no replica concept. We can see only single pod. Understand the difference? Process is same. Yeah. Same replica set we can give the access by using service. Deployment also we can give the by using service. Service only for looking that labels are match or not. That's it. Service cannot validate it is a pod, it is a deployment, it is a replica set. It's not like that. Clear? Terraform key already done, but I written in a notebook. I need to add into the soft copy. I will share the key. Okay. I just see. Just I have shared here, but I need to add into that soft copy. Okay. Just for your validation. If you have any questions after verify your validations, let me know. Sir, why 25 is 1? Why 20 is 2? If you have any questions, don't hesitate, you can ask. And as I said, I'm going to plan every weekend the test series explanation session only. Okay, Saturday, 1 hour. See, for example, the test series for Terraform 40 questions, right? So we can discuss 40 questions in that session only for only test series concepts only, not for any other concept. Okay. So like that, Git AWS also need to plan. Okay. Any questions you can ask me at the time. Sir, why this question is for this option? You can. Okay, guys, don't miss Kubernetes class. Okay, it's very interesting. Okay, the coming classes are a little interesting. So don't skip the class. It's very difficult to understand. Okay, that's all for today. So don't forget to delete the cluster. So same thing, kubectl, delete cluster. I will share the notes to you. Don't worry. Name. So headless region US East 2. Sorry, E case deleted. Okay. I will share the notes. Just give me time so that we'll share the notes for till here. Okay, that's all for today. Thank you, guys. Bye.